first, let me introduce myself. And
okay, right into it.
yeah.
We just went live. I think that maybe you thought we were already live 3 seconds ago, but welcome to Substrate Seminar, guys. I'm with Wenfeng here. He's
yeah.
core developer at Phala Network. He also goes by Wesley, so we can call him Wesley. Super stoked to have this presentation. Just a quick reminder, guys, that we have this new system where if you have a topic that you want to be presented on Substrate Seminar, you can do exactly what Wesley did, which is, hey, I have this cool topic about bridges that we're working on at Phala, and basically then kind of use our new repository for discussing about the topic and then eventually getting it on schedule for seminar. So please use that resource. There's a link to that at the bottom of this crowdcast, and you can also find it by searching Substrate Seminar GitHub on whatever search engine you use. Without further ado, how's it going, Wesley?
It's good. Actually, I'm very happy to be here to share the latest project developed by Phala team. Yeah, that's,
you know, it's funny.
SubBridge.
Yesterday, I was hanging out with Marvin, and he was making great jokes about. He was on a panel discussion, and so Marvin is a co-founder at Phala, and we're here in Berlin, and he said that. In the context of, what's Polkadot, what's Kusama, he said that basically Berlin is more like Kusama and Munich is more like Polkadot, right? So Munich people are more like civilized. Maybe you might not know this, having lived in Germany, but it was especially funny from hearing that from Marvin, who's come to Europe a few times. Anyways, it was great to have him on the panel. They were talking about metaverse stuff. And anyways, but yeah, now it's great because I get to talk to one of the core developers on the project that he's working on.
Yes.
So we're here talking about bridges. So I'm gonna just say it for those also watching right now. Like I'm learning a lot about these bridges, like the different bridges technologies out there. I actually don't know all that much at all. I tried to get some of my colleagues in the audience, hopefully they can be asking questions that are more relevant. But really, like for this seminar, I'm gonna just watch and learn what you're showing us today. I'm sure you have a lot to unpack. And by the way, you can, people watching, you can actually go onto the GitHub repo on Substrate Seminar and find this session as it's kind of laid down. There's a link to Wesley's slides there. So again, like, just feel free to read these resources in parallel and prepare your questions. So on that note, I might have a lot of questions. I might be interrupting you. I also invite the audience here to interrupt you if they do have questions, or maybe leave a few to the end. So I'll be moderating the chat. With that being said, let's get started. Why don't you just let us dive into the deep end with you. We're talking about SubBridge, developed by Phala, and it's a multi-chain bridging mechanism that we're about to learn about.
Yeah. Okay. Everybody, don't hesitate to ask questions. Yeah. Okay, so let's get started. Yeah. Let me open the slide. Okay. So since Sacha has introduced me, and I also can introduce myself again. Yeah. Hello, everyone. I'm Wenfeng from Phala Network, and I have been building blockchain over 5 years and participated in building SubBridge, Phala many modules, and other runtime stuff. Yeah. Okay, let's go through the content of today's talk briefly, and we will talk about the following topics about SubBridge. And the first is we will introduce you what is SubBridge and why we build it. And the second one, I will dive deep into the details about the implementation of the SubBridge. Yeah, and then I will introduce you how to integrate your asset into SubBridge. It's very easy. And then we will have some plans, and I will introduce the plans about the SubBridge. Yes. Okay, let's start.
Sounds
So
good.
what is SubBridge? Okay, SubBridge is a multi-bridge router of the parachains and bridging Sama and other ecosystems. So here is a key point is that and SubBridge actually is a bridge router, and it's not same as the general bridge. When we talk about bridge, we always say that it's a kind of bridge approach that move asset from one chain to another chain. And here, SubBridge actually is connect different bridges, and he can transfer the cross-chain transfer. He can forward the cross-chain transfer from one bridge to another bridge. That means through the SubBridge, users can issue a cross-chain transfer across 3 chains at the same times. So we will give you some details later. Okay, so far we have enabled the following functions, and the first is with SubBridge, people can transfer the asset between Phala Network and other parachains in the Kusama ecosystems. And then users can transfer the asset between Phala and chains like Ethereum and Monriver UAM. We know that Monriver is like a chain in the Polkadot ecosystems, and yeah, they have the SubBridge side and the side, and so with SubBridge you can transfer the asset to the side. Okay, and the last is that the user can transfer the asset from the parachain and to the chains directly. That means you can transfer the asset from Karura and to the Monriver UVM or to the Ethereum. You just need to give a right destination and send the message to the Phala Network, and the SubBridge will handle and forward it to the right place. Yeah. Okay, so why we build it? And earlier at 2020, and we built a demo, and that is use the XMM version 0, and we have a demo with the Phala Network. Actually, it's Phala Network, and we enabled the cross-chain transfer between Phala Network and Kura Network. That is the first demo built by the XM and XM version 0. And then in the 2021, and we have built a bridge based on the solution of ChainBridge. That is a open source cross-chain solutions, and we let users can transfer their PHA from Ethereum and to the Phala Network, and also can transfer from Phala Network to the Ethereum. So when we build these two bridges, we think why not to build a special bridge that can connect the parachains to the to other ecosystems, like to the ecosystems. So here we build the new bridge that named SubBridge that can connect the Sama to other ecosystems. So far, we have connected the Sama to the Ethereum and Monriver UAM, and where, of course, any other portable blockchain like BSC, etc. Yeah. And actually, here is some real demands that many projects and many I said we have. The first is that many projects in the chains, especially in the Ethereum and the BSC, they are struggling with high fee and low scalability. When you send a transaction and you may cost $15 or $100 maybe to pay the fee, and it's very high. And another is that some projects, they have issued the token on both the parachain and the chains. And for example, the ZLK, which is a token of the ZenLink project, they have issued their token on both the Bifrost network and on the Monzilla UAM. So they need to approach to that can transfer the ZLK between these two chains. Actually, we can think the Monzilla UAM like another ecosystems, right? Yeah. And after we build it, there are several advantages. And the first is that the parachains can interact with the EVM ecosystems without a bridge being integrated into their runtime. They just need to integrate the XMM protocol. If you want to communicate with other parachains, no matter you transfer assets or send messages to other parachains, you need to integrate the XMM protocol. This is the only thing you need to do. And then you just need to follow some spec of the destination and send this message to the Phala network. And so the SubBridge within the Phala network can recognize and forward this message to the ecosystems. And on the other hand, by bridging to the Polkadot ecosystem, the many projects can benefit from the scalability and the interoperabilities of the Polkadot network. Okay, so this is SubBridge. Yeah. Do we have any questions?
Before we go into like the implementation and which is the next slide, which I'm excited about. I was just reading up on the chain safe palette, essentially that I believe that is part of your implementation. But my question is, you guys built already some bridges, right, between the Phala and Phala and EVM, and now kind of this year you're working on a bridge where you're really trying to address the need for bridging between like standalone parachains with other non-parachain chains. What are the biggest challenges that you've learned about building this kind of technology in this third iteration, right? What are the things that you had to overcome? Like what was the really most difficult problem that you had to solve in order to get where you are today?
Yeah, I think the most part we have overcome is that different, because the SubBridge actually is a bridge router, and it connects the different bridges. And the first thing we encountered is that we must have unify the asset and the destination between different bridges, and thus we can forward this asset and the messages between different bridges. So, but thanks for the XMM protocol, we found the solution in the XMM protocol. I will talk to you in the next slides. And the second one is that different bridge implementations have they are very have many difference actually in the implementation. And For example, under the XMM protocol, we can build a bridge that can transfer access between the parachains. And based on the XMM protocol, we build a bridge actually use the XMM module that implemented by the Polkadot network. And yeah, actually they contains the instructions or registers or any other specs. But when we here another side, we integrate the chain bridge as our bridge so far, and its implementation is different with the XMM protocol, and so we need to combine these two parts together. And I think this is some work that we must to do. Yeah.
Mm-hmm. And in doing this work, what other competitors, or not even competitors, but what other work is being done that maybe you're either borrowing inspiration from or designing, bearing in mind that these aren't maybe design decisions that you want to take? What other things that are kind of trying to do the similar things that you might have seen, or maybe not?
I think actually we may we have many things that when connect the different bridges, that, for example, the fee that we how do we deduct the fee that between the two bridges? Sometimes if you issue the transaction from other parachain to the chains, then the transaction were across 3 chains, and actually they were across 2 bridges. And how do we deduct the fee? And this is how a tough place that we need to handle.
Mm-hmm. That's probably a really hard problem to solve in this. Yes.
Yeah.
Cool. I'll let you continue. I'm excited for the next section.
Okay. So let's dive into the implementation. Okay. So here is the topology of the SubBridge, and from the left side, you can see that Phala Network is one of the parachain of the Kusama network, and we connect many parachains through the HRMP channel, and we through the XMM protocol, and we all know that we can transfer the access between parachains and also send messages between parachains. And the middle side, and we can see we have the chain bridge and the ongoing one bridge integrated into our runtime. And through the bridge, we can connect the parachains with the chains. So this is the topology. And so I will give you a brief introduction of the XMM protocol, because I guess not all of you have used the XMM protocol actually. So let's just get a description. And I think we can divide the XMM protocol into 4 layers. Actually, the Polkadot network, the Polkadot doesn't divide it into this 4 layers. I just think they can make it more clear. And the layer 0, I think it's the relay chain and the parachain. So it's all about the blockchains. And under the layer 0, we build the layer 1. Actually, it's 3 protocols. Is XMP used by the parachains to communicate to each other, and the UMP used to send upward messages from parachain to the relay chain, and the DMP protocol is used to send the messages from the relay chain to the parachain. They are just a message format, and those messages then tell us the message. How can we generate the messages? And under these 3 protocols, we have the Polkadot has built the XCVM. It is a kind of virtual machine built on top of the XMM protocol, and it's first introduced by Gavin in his blog, and so that this XCVM actually contains the instructions and registers, and now we on top of the XMM, that's what we have built is build a SubBridge and or message distributor, and we just use the instructions and registers, just like we write code on the computer. The low level of computer also contains the instructions and the registers. So it's kind of like the same things, I think. Yeah. And on the other side, from this slide, we can see on the other side, we have integrated the chain bridge to connect the Phala Network and the UVM chains. So the chain bridge, what is chain bridge? Chain bridge actually is a open source cross-chain solutions. It support both the Solidity part and the substrate part. So we can easily integrate it into all runtime. And so far, we based on the ChainBridge version 1, and we have run 3 layers to run the ChainBridge for the transaction. Because as you can see, the topology of the ChainBridge also is very simple, because when we transfer the assets between chain A and chain B, for example, we send the CrossChain transfer, we send from chain A and to the chain B. The relayer would observe the event and trigger in the chain A and construct it as a proposal. And the relayer would vote this proposal, and when the proposal is passed, and then execute the proposal, then and finally the asset would be disposed into the right account, right recipient in the chain B. So actually we have 3 layers run, and only 2 or 3 layers vote the proposal. We can execute the proposal. Okay.
So basically, the relay here is some Phala node of sorts that is acting, well, that in its runtime has some pallet that is acting as this relayer, basically between 2 chains, and settling, any balances on both sides, as well as fees and all of that. Is that correct?
Actually, it's not part of the layer. Is not part of our runtime, and it's a standalone program that provided by the chain bridge, and we just run 3 layers, and as you just said, the Phala node can run everywhere, and we run 3 layers, and they are maintained by Phala official.
Right. So okay. So to put it differently, then these relayers are using Phala's off-chain compute in order to run.
So far, it hasn't used Phala off-chain compute. Yeah.
Okay. That makes sense. Yeah. Cool.
Yeah. Okay.
Yeah, I guess for those watching, and please again, ask your questions as they come. It makes it sort of more part of this format where we're all kind of learning here. So ChainBridge is developed by ChainSafe. ChainSafe has created a pallet, but it has created a pallet a while ago. I'm assuming that maybe you took you used some of their code, but you're maintaining it now yourselves. Because last I checked, I think the last commit was almost 2 years ago in that palette, right?
Yeah, actually.
So are you working? Are you collaborating with ChainSafe in any way, or is this just technology you're reusing for your own purpose and you don't need to depend on that project anymore?
And the initial version of ChainBridge is very simple. We have collaboration with them, and when we the implementation we use is ChainBridge version 1, and we are working with the ChainSafe team to update it to the version 2, and this is what we are doing now actually. And the version 1 actually we have put it to our Phala Network in Phala runtime, and we have some customer definitions on
Cool.
the ChainBridge.
So yeah, that's super cool. Yeah, I gotta say, I said the last commit was 2 years ago. That's not true at all. I mean, the last I think was about 8 months ago, but still, yeah, that's. And I did post it in the chat if you guys are curious in checking it out. The better thing to do would be to see where that code lives in Phala, but I'll let you continue, Wesley.
Okay, and by the way, all the runtime code, of course, the runtime code is open source of Phala Network, and the relayer source code and also open source, and everyone can check it. Yeah.
Cool. Yeah. Sweet.
Okay, let's move on.
Yeah.
So we can, okay. Any questions?
Yeah, there's a question, but maybe you want to just go through this slide and then we can ask this question.
Okay.
Yeah. So we're really kind of getting into the architecture of your implementation, right? So we just learned about where ChainBridge lies, and now I'm assuming you're gonna go a little deeper. And then I think it's a good time to ask a question. Yeah.
Yeah, if anyone have questions, you can ask me at any time. Yeah. So let's move on. Okay. So SubBridge is a router of different bridges, and that means I just said that it can forward the CrossChain transfer from the parachains to the chains, also from chains to the parachains. So from this slide, you can see that when the parachains have a cross-chain transfer, for example, someone want to transfer their PHA from Karura to Ethereum, and he sent the transaction on the Karura network, and we can see that this message will be wrapped into a XMM messages, and the XMM message, we have the XMM bridge to handle this XMM message, and when we recognize the asset and the dest, we have the asset and the dest from the XMM bridge, and we recognize and handle the destination. And if we found that this transaction is not transferred to the local Phala network, because of course you can transfer the asset from Karura to Phala network, and if we find the dest is not in the Phala network, but a chains, then we will use a bridge that support to deposit the specific asset on the specific destination, and so we use that bridge to forward this cross-chain transfer to that chains. So maybe
this would assume though that on both ends there is on both the receiving end and on the sending end there is an interface that can talk to each other, i.e. like on the parachain side we need to have an implementation of XEM that the destination needs to understand, right?
Yeah. Yes.
How do you see that being an overhead, if anything, or how do you see that sort of playing into ways or how developers need to work with implementing this kind of tech?
Yeah, this is actually an interesting part, and I will introduce you later, and
okay, cool.
About how to integrate your asset with SubBridge. Yeah.
Okay. So yeah, I'll let you.
Okay. So as you can see, that the way that we decide how to how to forward this cross-chain message is according to the ISET, and the destination the user passed to the SubBridge. So the first thing we need to unify is that how we define the ISET and how we define the destination, because actually we are connecting two different ecosystems. Yeah, the parachain ecosystems and the chains. So the first thing we need to do is unify the ISET and destination format. So as I said, that sorry, here has a tab. Let me fix it. Yeah, actually we have it's not ISET. So thanks for the XMM protocol, and we have the multi-ISET, which is a universal ISET identifiers used to describe a ISET. And we also have a multi-location also introduced by the XMM protocol used to identify the a location of the whole parachain network. I will tell you later about how we extend it to the ecosystems. So first, let us see the multi-ISET. In the left side, as you can see, is a JSON object, and it actually here is represent one PHA. The decimals of PHA is 12. So actually the field FU actually means one PHA is the amount of the one PHA, and it has a ID. This ID actually is a multi-location. Here we talk about is a concrete fungible ISET. Actually, multi-ISET can represent both the fungible ISET, non-fungible ISET, or also concrete ISET or non-concrete ISET. Yeah, it's very powerful. And here we talk about is like PHA is a concrete fungible ISET, and so the ID is a sort of multi-location, and the ID is so we can see that the multi-ISET gives the ID a multi-location type. That means this is where the ISET come from. So here we define that this is the location of PHA, and so let's just say the multi-location, and then you can you may be more clear. And the multi-location is a universal consist location identifier introduced by the XMM protocol. So under the multi-location spec, a location is just like a file structure of our directory. It's actually a directory tree, just like a directory tree of the file system. And like on top of the whole system, we would say it is the root director, and here it is the relay chain. Actually, it's the Kusama or the Polkadot network, and under the relay chain we have many parachains, and under the parachains we have a pilot or account or anything else. So here if I have an account under Phala Network, that means Wenfeng.1. So here is my account. From the right side, you can see that here is my account on Phala Network, and here is actually we use the multi-location to we use the left multi-location to represent this account under the Phala Network. So it has two X2 junctions, and two junctions. The first is the parachain ID, then is the parachain with the parachain ID 2004, which is the parachain ID of the Phala Network, and the last one is actually because we use the account ID 32. So here is my public key, and we just put it into this object. So here is multi-location. And with the multi-ISAT and the multi-location, we have the way to unify the ISAT and destination, and the rest of the thing we need to do is to recognize the location, and to SubBridge, we have a spec to let you need to let the users to follow, and so we can recognize it. Okay, so let's see some examples. Here is 2 examples of the general terms of the destination we often define in the Dosama. And if we would like to transfer asset between parachains, we often need to specify the destination, and the destination may be kind of like this. And actually, it is a location and with 2 junctions. The first is the parachain, and the second is a account type. Here is account ID 22, but sometimes, for example, with Mozilla network, and you may use the account key 20. So different network may have different account type, and yeah, okay. So here is the parachain account, and if we want to transfer some asset to the relation account, and what we use to represent the destination is a multi-location with parents set to 1, and no parachain junction, but just a account ID 22 here to identify the account public key. So here is the general terms. Okay. So since we have the with XMM Protocol, we have the way how to unify the asset and especially the destination of a account on the parachain network. So how we extend the destination to ecosystem. For example, how can we use the multi-location to represent an account under the Ethereum network? So we can see that in order to represent an account under Ethereum network, we must have the following informations included in your destination object. The first is we must have a recipient address. For Ethereum network, it may be a 20 bytes is a hexadecimal bytes, right? And maybe for other standalone chains, they may not use 20 bytes or any other nonce. So we just use a dynamic byte to represent the recipient address. And another one is that we need to know that which chain we need to forward to through the according to the destination. So another information we must have is chain identification. Like we have to assign a chain ID to different chains. So here we use the general index. It is also introduced by the XMM protocol, and it's a kind of junction. And we use the general index. It's an integer to represent to let user to specific a ID of the chain that they want to send to. And
can you just give an example, like what would the chain indication, the EVM chain indication look like? Like is that just like when you're connecting a different chain via MetaMask, you're gonna give it a certain ID, right? Is that what you're talking about?
Yes.
Okay, cool.
But it's not. But it's assigned by Phala Network. It's different from the ID in the MetaMask.
So you have some sort of registry of different chains that you can interact with, and developers need to know which one corresponds to which one by looking at whatever.
Yeah.
Yeah. Okay. Cool.
Yeah. And the last and is the most important part is that the what thing you need to do is the first thing you need to do is that you must send this message to Phala Network, and then we can forward it. Because as you can see that if you send the CrossChain transfer on other parachain like a Karura network, and you want to send it to the Ethereum, and so the first thing you need to send this message to Phala Network, and so that we can recognize the destination and forward this message for you. So we must have a parachain junction in the destination. Okay, so with these three necessary information, we can. So the way we just we do is to make the become a subconsensus of Phala Network, because as you can see here the example from these examples, and actually we have the following definitions. Like if you want to transfer to an account from the Phala Network, and you give this three junctions. The first is bridge, which I didn't told on the last slide, but this is optional, and so far we have to specific a chain type, which means which chain you want to use, which UAM chain you want to use to forward your cross-chain messages. And the second one is the chain ID. I just said that we need to know that which chain you want to forward to. And the last one is account on the chains. Yeah. While here the parent is 0 is because you send this message just on the Phala Network. And if you send this transaction like from Karura, and you will have a X4 junction, and the parents need to set to 1, and so that the XMM module within the Karura network can forward this message to Phala Network properly. So when Phala Network receives this message, and actually it will become the first one, and the destination will become the first one, the first MultiLocation. Yeah, just like this, so that the SubBridge can forward this to the right chain. Yeah. So yeah, so the clients only just need to, if you are a parachain, for example, the Karura network, if they want to let their user transfer the assets to the chains, they just need the client to follow the spec, and no runtime modification needed, because all thing you need to do is to integrate the XMM module. Yeah. Okay, before
that's actually huge, right? That last point you made is huge. It's for other parachains to integrate this, they don't need to actually do runtime upgrades. They don't need to like be including new runtime code. All they need to do is to, in order to use it, is to provide, basically to understand what chain spec they need, or what would you call this? A large JSON spec file that makes their client side know how to interact with the router. Is that a good way of saying it? Like for a parachain team to know to use this, they need to be doing what on the client end?
Yeah, actually, if you transfer to, for example, if you issued the cross-chain message on Karura, and if you want to transfer the asset like PHA to Phala Network, basically, yeah. So we can see at here. If you want to transfer the asset to an account under Phala Network, so this is a transfer between parachains, just between parachains, not related to the chains. You just give the it's general format of the destination, and it's just the parachain ID and account public key, and you set 2 of this, and you will send this message, and the Phala Network can handle it. And if you want to send the asset from the Karura to Ethereum, for example, Ethereum, all you need to do is just change your destination. Just change your destination to a X4 junctions. So here we can see it's a X2
all you
junction.
need to know is that junction ID or whatever, right? Like
yes.
And the Phala side of things will handle that or route that message correctly.
Yes. Yeah.
How does it handle like errors? I mean, like what could go wrong?
Yes, sure, it will go wrong. Yeah.
Well, what can go wrong, right? On the end of on the Phala end of things, like what could go wrong in this scenario where a message just won't get sent? What's the latency involved? I don't know. What like how do you handle sort of the less happy scenario of this working?
Yeah, just like the I think every cross-chain transfer will failed if something happened, and including the XM the cross-chain transfer based the XMM protocol. If the asset haven't been registered on the destination chain, or the fee you set is not enough, it's not enough to buy the weight, and the transaction will fail. And so this is different how we handle this failure with different chains. When we on the XM part, on the XM cross-chain transfer part, if the transaction, for example, you send the message from Karura to the Phala Network, if it failed on the Phala Network, the asset would be locked. And if the asset is less than the essential deposit, and it will just be slashed to the treasury account. And if it is more than the treasury, the essential deposit, and then the asset would be locked, and you need to send some special messages to reclaim the asset locked in the Phala Network. And on the other side, you know that we have a chain bridge based bridge, and this part, that the transaction also would be failed. For example, like the layer is down, or the asset, the amount that you transferred to the Ethereum, because you transferred to the Ethereum, we need to pay some fee to send this transaction. And if the amount of your asset is less than the fee, and it will be failed. And if the layer is down, and the transaction will be failed. And if the layer is down, and we can reboot the relay, of course, restart the layer, and the layer would continue to pass this block and forward the transaction to you. But all we can see that it's we cannot guarantee a transaction must success in the destination, because there are many scenarios that we may be encountered. Yeah.
So this is like in bridging jargon, so to speak. Today you have this concept of optimistic like finality, right? And so what you're just describing is essentially that, where we can't be absolutely sure there is a strong enough guarantee, but if something goes wrong, it'll roll back and could have one of many different states. One of them would be that the asset is locked, and then we need to do some I'm assuming some governance-led transaction to unlock it.
Yes.
Okay.
Yes. Yes, especially our smart contract deployed on the chains, and we have a much because unlike the substrate side, we have the console and we have the government module, and on the Solidity side, yes, we have a admin account, and it is a multi sign, and we use the multi sign if the asset of the users is locked, and we use the admin account to release it to the user.
Super interesting. Yeah, cool.
Yeah. Okay. So let's see some examples of the examples life cycle, and to help you understand how the SubBridge forward the cross-chain messages, and also we can see cross-chain transfer so far. Yeah. And the first is we just send the PHA from Kana to Karura, and under this scenario, then you can see that we just sent the transaction, the cross-chain transfer between parachains. So here you can see that the destination is with a X2 junctions, and we specify the parachain ID of Karura network is 2000, and we specify the recipient public key, and so it can. So when we issue this transaction, we will give this destination to the SubBridge, and it can transfer it can recognize that we need to use the XMM bridge to forward this transaction to Karura network. So this is the simplest one. Yeah. And another example is when we transfer the PHA from Phala Network to Ethereum. Yeah, that means we issued the cross-chain transfer on Phala Network, and all we need to do to give the destination is we specify a X3 junction. The first junction is a literal characters of CB. That means we are going to use the chain bridge to forward our transaction. Yes. So here we specify the bridge, and the next one is chain ID. We use the general index to represent it, and the ID of 0 is the ID of Ethereum. So this transaction would be sent to Ethereum, and the last one, of course, is our account. Is our account address on the Ethereum network, and as you can see that we found that suppose we have two bridges, and the first is chain bridge and the second one is one bridge, and the first chain bridge suppose transfer asset from our Phala network to Ethereum, and the one bridge suppose transfer asset from Phala network to Moonriver UAM, and from the destination we can see that we need to transfer the asset. The user need to transfer the asset to the Ethereum. So the SubBridge will iterate the bridges and to find which bridge can support to transfer the asset to the destination. And it finds that the chain bridge can do this. So we use chain bridge to forward this cross-chain transfer to send this cross-chain transfer to the Ethereum network. Okay. And here is a little bit complicated one. And if we transfer the PHA from Karura to Ethereum, so this is the most interesting part of the SubBridge, and we can transfer asset from another parachain to the UAM chain directly across 3 chains at the same time. So under the Karura network, we give the destination of X4, and of course the first is the parachain. The first is parachain, and with the parachain ID 2004, and that means the XMM module of the within the Karura network, it will forward this message to Phala network, and then when Phala network received the message, and it will have the new destination with the last 3 junctions, and the first is CB that just like the previous one, and we have described that. Yeah, we know that we need to forward this CrossChain transfer to Ethereum, and we know that we need to use ChainBridge. So here we just we get this CrossChain message from the XMM bridge initially, and then we have a new destination, and we recognize that it will need to send to the Ethereum, and then we send it to the Ethereum network with ChainBridge. Okay. And from the other direction, and of course, user can send their asset from Ethereum to Phala Network directly. Yeah, this is how it works. And under the Ethereum network, when user use our ChainBridge smart contract deployed on the Ethereum network, and the most important part is that actually we will give the recipient a special bytes. It's a encoded MultiLocation object, and the MultiLocation is a destination of a it represents an account under the Phala network. So from the destination, you can see that with Parachain 2000 and a public key, and so this is an account under Phala network. So we just need to to encode the MultiLocation object and set it as a recipient. And when Phala network, when SubBridge get these messages, and they will find that the destination is not an account under local Phala network, and it is a destination that on the Phala network. So it will when they received the message from the ChainBridge, and then it will forward this message through the XMM bridge to Phala network. So this is how it works. So this is the life cycles
in that
of
scenario,
scenarios.
What happens if the account doesn't exist? So yeah, what would happen in the scenario where there's a message trying to be sent from an Ethereum chain or from Ethereum, and the destination is non-existent? Will that message go through, and will fees need to be paid on the sending side regardless, and it'll get rolled back? Or like, what happens in that flow? Yeah.
Yeah, I think actually I think that there may be no extension deposit or something else in the ecosystems, and our account, if we just give a 20 bytes of an account address, and it will always deposit ISIS into that account. If you give a wrong address, or that address that address doesn't exist before, and
but if if you gave a non-existent parachain ID, for example,
we can. Yes, this is if you give a unsupported parachain ID, and from the event bridge, right, and to the to SubBridge, and SubBridge will not forward this transaction for you, and that means the transaction would be failed on the Phala network. So this will fail on Phala network, and this message will not forward to Karura, of course. And when the transaction is failed on Phala network, and the asset will be locked in the Ethereum. Yes, asset will be locked in the Ethereum. And when we find that the asset is failed on the Phala network, the user and we both know that this transaction is failed, and we need to handle this failed. We need to handle this failure. So we will use a multi-sign admin key to unlock the locked asset to the user. Yeah. of course, we will see that. We'll see the history, transaction history from the blockchain. Yeah, make sure that everything is correct. Yeah.
Super interesting. Yeah, cool.
Okay. So actually, we have a demo, and before we go into the demo and any questions,
yeah, there's a few questions. Actually, Hang has been active here answering one of the questions, but I guess I join Robert, who asked the question, because it was confusing in the beginning for me, because I assumed that all of this is making use of the SGX off-chain compute model that makes Phala very unique, right, as a chain. So the question was, are you planning to be leveraging Intel SGX and TEs in the future for this?
Yeah, I think so far we haven't have a plan to integrate it into the SGX module, and because so far because of the implementation of the chain bridge, the layer is actually we cannot run many layers, because each of the layer would send the vote transaction and send the execution transaction to the Ethereum when they observed a CrossChain transfer from the Phala network. And if we run many layers, that would be need to pay many fee, and that the fee in the Ethereum is very expensive, and we cannot run many layers. And but we so far we just integrate the ChainBridge version 1, and we are integrating the ChainBridge version 2 once they released. And under the ChainBridge version 2, the layer is not maintained by Phala network, and it were maintained by the maybe ChainBridge just provides this layers, and it is totally decentralized, and
okay,
just
so
need to send one.
That was my follow-up question. I asked also in the question bank here, which is so this is all using the ChainBridge's kind of model, right? Where the initially it was a palette, and you guys integrated it into your code base. So it uses this trusted federation model. Where is that in all of this? Where, like, who are the trusted federates, right? I'm curious.
Yeah.
If that makes sense.
So you mean how we build the trust of the relayers?
Yeah. Like, what are these relayers? Like, are they analogous to validators? Maybe to some extent. Are they specialized clients that are being run to provide consensus? How is it really working? Like, it's not very clear to me.
In the ChainBridge version 1, so far the version that we integrated into Phala network, and the layer is not just it's not like a validator. It's like a standalone program, and they just do simple thing is to observe the event from the source chain and vote and write it as a proposal and vote this proposal and executing the transaction. So here, this 3 layers is their address is right into the smart contract, and everyone can know what the relayer have done to the smart contract.
So Shelvin also added to what you're saying, and now it makes a lot more sense, which is that this trusted federation model doesn't it's not really an integral part of SubBridge. SubBridge is just focusing on the routing part.
Yes. We're just focusing on the routing part.
Yeah. Cool. That makes a lot of sense. And I had a final question, which was, what are the advantages for parachains to be using SubBridge over doing their own XCM stuff and implementing their own bridge. And I think we partially talked about this a bit, where basically like the advantage is mainly you don't need to update your runtime. You just can use this hub to do cross-chain assets, not only within the parachain ecosystem, but also outside of the parachain ecosystem, which is really powerful, right? But at the same time, there's maybe decisions, or maybe there's certain chains that think that they could be more efficient with implementing just what they need or whatever. What would make it attractive to actually use SubBridge? Like, is there anything that you like from the maybe more of a business perspective, right? What makes it really attractive to use SubBridge?
I think for me as a developer, is the most attractive thing is that we can send a cross-chain transfer across 3 chains at the same time, and actually with more and more bridges we integrated into our runtime, and actually we can choose a most efficient bridge to forward or cross-chain transfer, because many different bridge may have different implementations, and they may have different fees you need to pay, and we can give user a best path, and we can choose a best path and the cheapest path, and the user can save their cost.
Yeah, I mean the overhead is definitely clear and a very clear value proposition for sure. Cool, Wesley. I'll let you keep going. I guess we're almost running out of time, so if we had a demo in mind, let's jump right into it. This is really interesting. I think so it's the first time we have as much retention of active viewers right now.
Yeah. Yes. So first, let me introduce the topology of the testnet, and we have used the Polkadot launch to run a parachain network. And the middle side, we have a chain bridge. We have run one chain bridge layer and used for the cross-chain transfer between the Phala Network and the Rinkeby. The Rinkeby is a UVM testnet, and so we can just treat it as the Ethereum because it's the same. Yeah, it's just a testnet, and the Phala is a test parachain of Phala Network, or you can say as Phala Network. And this demo we will transfer PHA from the Ethereum and to Karura. And then we will transfer the PHA from Karura network and to the Ethereum network. So let's get started. Okay, so first we need to transfer the asset from Ethereum, and we need to have interact with the smart contract we deployed on the Rinkeby network. Okay, then first let me check if my testnet is still alive, because I run it in the Docker and it may be done. Yeah, it is good, and it is good. It has produced products. Yeah. Okay. So first we will use this. Let me inside my terminal. Can you see it now?
Yeah, that's great size. Yeah, thanks.
Okay. So let's just go through this script, and let's see what I do. And we have a recipient first, and have the transfer amount, and we use the Phala API. Actually use the Polkadot.js and to construct a MultiLocation. This is the only thing because also we need to, as we said, we need to construct a MultiLocation to a real recipient. Yeah, and then we have some like the Ether wallet used to wrap our account, the center account, and we have a bridge smart contract. We have constructed a bridge instance on the Rinkeby. And if the dest is Phala and we transfer the PHA from UAM to the Phala network, and if the dist is Karura, and we transfer to Karura. So here we just transfer the ISIT, the PHA to the Karura network. And I need to say that we have a test PHA, not a real PHA, test PHA deployed on the Phala network. So let's just do it. And here is a command line, and from this command line we can see that we set the dist is Karura, and this is the recipient of the Karura network, and we give it a 22 bytes public key, and the amount is 600, and we just execute it and see what will happen. Okay, so this script is to send the cross-chain transfer from the side, from the Ethereum, I can say, and then it will be transferred to Karura network through the Phala network. So we can see that this transfer is, we have a transaction hash, and we can see it in the Phala network, and yeah, I can. It is still pending, and index it is success, and we can, from this token transfer, we can see that it transferred 600 PHA, Phala PHA from the sender account. Actually, this is the sender account, and to our smart contract, to one of our smart contract, because this asset is locked. And back to this window, and we can see that the relayer, this is the relayer, this is the Cambridge relayer. They just forward this transaction to Phala network, and from the Phala network, here we can see that the Phala network, this is a block number, this 3292, and yes, just the latest block, and it forwards this cross-chain message, and we can see that it forwards the ISIT, which the ISIT is 0 here, means the for Phala network. This means this is the ID of PHA, and to the destination of with parachain ID 2000. So we can see that it to the Karura network and with account ID here. And so on the Karura network, we just see here is a blockchain number. It's the latest blockchain number almost, and they just deposit this ISIT. And you can see that we send 600 PHA, and some ISIT, a little amount of ISIT are deducted as fee. So you actually received the 599 PHA. Yeah. So
cool.
This is the.
So
yeah,
when you showed the
Ring
QB, when we showed it with the Etherscan, right? Where that's really like we can think about it as the relayer has locked that, and then the relayer relays that message onto to send an XCM success essentially message on the Phala side or Karura side.
The way is that the ICT is locked into our smart contract, and not into the relayer account or any relayer related things, and then it will send this cross-chain transfer through the format defined by the chain bridge, and the SubBridge will forward it and wrap it to a XMM messages and send it to the Karura network, so Karura network can recognize it. So like here. Okay, so we just send the PHA from the Ethereum to Karura network. So let's just do another demo, and send the PHA from Karura to Ethereum. Okay, it's also very interesting. First we need to have transactions use the X token that's provided by this is the module that also this is the palette that used to do the XM cross-chain transfer within Karura network, and we choose the PHA and we give it amount like 6, for example, we just save, because the fee we set is 1 PHA, and we just transfer 7 PHA, and we will receive on the Ethereum side almost 6 PHA, and not equal to 6 because we have some fee to deducted on both XMM bridge and the chain bridge. So we have 12 zeros here, and we specify the destination with parents 1, and the junction need to be 4 because we need to send this transaction to Phala Network, and then we specify the bridge type with CB. That means we use the chain bridge to forward this CrossChain transfer, and we generate index to identify the chain ID of the Ethereum. So the Ethereum chain ID is 0, so we just put 0 here, and we use the generic key to represent a account on the Ethereum. So we just copy my link by. It's just one of my account. I just put it here, and so here because we send a XML message, so we need to specify some test win. Okay, so we show this transaction. Okay, we can see it from there. So this transaction is sent from the Phala Network, and we need to go to the. We just go to the Phala Network. So here is Phala Network, and let's see what will happen. Oh, we got it, and the X transfer forwarded, the SubBridge forwarded, just forwarded to the destination of. Here you can see the CB00 means it will be forwarded to Ethereum, and with to deposit asset into this account. Okay, so here is a chain bridge event that the relayer would observe. So let's see the relayer and check if it has observed the event, and it hasn't, and yeah, it got it. So here, this relayer just submit a vote proposal, and with we have a theta a transaction hash, and we just can say it in the Explorer, and as we can see, this transaction is stuck because this is the live network, is not a local network. The transaction may be stuck, so we can move on or slide, and we'll check it later and see if it has succeeded. So from this side, if the relayer forwards this transaction, it will deposit some asset on the link by. Okay,
super
so
cool.
we just leave this proposal, and we just go on to introduce how to integrate your asset into SubBridge. This is I think someone will very interested in. And so far we have supported the following assets, and of course first is PHA, and yes, it's all native token, and we also support the Kusama, the Phala Network token KR, and the Bifrost token, the Zinning token, and also the stable token of Akala is AUSD. And we can see that for the PHA, we have opened the bridge that can transfer it to the Ethereum. And for the ZLK, we have enabled the chain bridge, and it can transfer the asset from parachains to Mozilla and it cannot transfer. We cannot transfer ZLK to Ethereum network and Ethereum mainnet, and we can transfer it to Mozilla So this is all configurable. So configurable. So we can specify which network that your asset would like to transfer to, would like to bridge. And here is a link of our wiki, and under the SubBridge wiki, under the capture of supported assets, you can check the latest supported assets. And speaking the how to integrate your asset into your SubBridge, as I said, it is very simple because you don't need to have any runtime modification. Rather, like if you need to support the PHA, then you must register the PHA into your XMM trader, just like that. And or if you are a parachain project and you have a parachain asset, and all thing you need to do in the runtime is to integrate the Polkadot XMM into your runtime, because no matter you communicate with Phala Network, and if you want to communicate with other parachain, you need to integrate the Polkadot XMM protocol. So actually, this is not part of the SubBridge integration, but it's just necessary to enable the SubBridge cross-chain transfer. And if you are a UM chain and parachain asset, both UM chain and parachain asset, all thing you need to do is to register your asset on Phala Network. So no matter the XMM protocol or on ChainBridge implementation, and we all must know that your location of your asset, and we must give your asset an identification. So this is the only thing you need to do. And we also have provided an documentation, and you can check it for the integration guide, on our wiki. So this is we need to do. Okay, before we go into the further plan, we check again. Oh, this transaction is still stuck. We are not lucky, and the transaction is stuck. Yeah, so let's just go on, and
Life goes on.
Yeah,
it'll
just
unstuck.
go on. Okay. Here, So next one is our future plan about SubBridge. What we'll do next, and the first thing we are doing is that we are integrating OneBridge. It actually also a UAM bridge, and so when OneBridge integrated into our runtime, we will have two UAM bridges, and the user may have more choice. And compared with the ChainBridge version 1, and the OneBridge will have less fee cost and more effective. And of course, we are going to upgrade the ChainBridge to version 2, and once they released, and I guess it will be released in a couple months. And then we will upgrade the XMM protocol to version 3. We know that the XMM version 3 is under audit, and the most interesting thing that XMM version 3 support is that the first is it will support the non-fungible transfer, and we can transfer NFT between parachains. Also, SubBridge will empower the NFT transfer between parachains and UM chains or any other chains. Okay, so and the second one is more friendly interface for indexing. When user transfer a cross-chain transfer between different chains, and the most important thing for them is to know where their asset now, and did it success or fail. So they are very aware of this. So we will provide the index service to give them a life cycle of the cross-chain transfer. Okay, and another thing is that SubBridge will support more solo chains, more standalone chains, including Solana, Near, etc. And in the future. So our only goal is to connect more ecosystems with Sama ecosystems. Okay, so here is
super cool.
What SubBridge is, and here are some references. Okay, thank you. Any questions?
That was awesome. Wesley. There's no questions I mean, you covered a lot. I know that there's people that maybe have joined just in the last 20 minutes. I really recommend that you go through the presentation. Interesting questions came here and there. And at this point, I mean, I'm just impressed at how you guys are like really using existing tech and really composing it and being innovative in what you're doing and leveraging like you as a parachain and what you can also offer to other parachains. So that's really cool. And specifically, I mean, leveraging technologies like XCM, like the chain bridge, and making your own thing, right? And it'll be really interesting to see this reach some sort of get more popular within different chains and see what niche use cases, why people are going to choose this over others. And I think this is just a great resource for people interested in that. So thank you for providing that for us. And if there's no more questions, maybe we can wait a minute or two. Yeah, Rutger says he's 100% watching the replay. Yeah, I mean, this was a little longer than usual, but sometimes presentations like this, we really need to kind of first understand the problem and understand the approach and then demonstrate what the solution is. And I think it's fair to say this is just the first iteration, so it'll only get more and more interesting, especially for those doing NFT transfers, cross-chain transfers of NFTs with XCM v3 coming out and being audited soon. So again, thank you so much. Do you have any last words for people interested in following the project or collaborating, or any last words you want to leave us with today?
Yeah, I think SubBridge is a very interesting thing, I think, and it's not just a general bridge, but it's a bridge router and can connect different bridge. When we connect different bridge, and actually we connect different ecosystems, and this is very, I think is super interesting because the Polkadot network is always have the scalability and the interoperabilities compared with other standalone chains, and we think if we connect it together, it will have many interesting things happen. And another thing is that I think the XMM protocol is very powerful, and as you can see that the SubBridge is built based on the extension extension of the XMM protocol. We use the multi-ISIT and MultiLocation introduced by the XMM protocol, and we just use it to unify the ISIT and the destination across all the different ecosystems. That's the power of the XMM protocol, and I think with the XMM protocol version 3, we will see many more interesting things happening in the Polkadot ecosystems. And yeah.
There's just one question that I think it's worthwhile answering for the sake of being complete, with regards to how is multi-location being used. I'll give my answer, and maybe you can finish the seminar with how you guys have sort of innovated with XCM, not just for what its intended purposes, but for the purpose of using SubBridge. And for me, the answer is that you're really in the relayer. So this whole model is thanks to having a relayer or a router, sorry, you call it. So the router's role is to basically relay messages coming in and out of it. It could be coming in from a parachain out to a non-parachain blockchain, or it could be going to other parachains. And in that relayer, the actual XCM between parachain logic is one thing. The other part is that we have this kind of new way of using XCM to create a communication layer between parachains and non-parachain chains. And it's not XCM as we know it between parachains. It's sort of a new flavor of using XCM.
Yeah. Yes.
Cool. Okay, so I got it. Thanks for asking that question, Danny.
Very
I hope that
interesting.
answered.
Very interesting. Yeah.
Sweet. Well, with that being said, thanks everyone for being here and for participating. I, again, always encourage you guys to also propose your topics using the Substrate Seminar repo. It's been great having everyone, and we'll see you in 2 weeks. Thank you so much, Wesley.
Okay.
And cheers
Thank
to
you,
the
everyone.
Phala team.
Bye.
Bye.
Okay.